Great. Thank you so much for having me. I am really excited over the next 15 minutes or so to talk a little bit about the use of physiological sensors or biosensors in business and in research. I'm going to focus today on eye tracking and facial coding. Although we do work with many other sensors, these two are definitely the most popular and common, especially since they have the unique opportunity to take those sensors out of the lab and to be able to collect data remotely, which is a real game changer for people who don't have access to this technology normally. Now, why am I even talking about biosensors within the context of commercial or industry applications anyway? Well, as we know from Economics 101, we know that people are not truly rational beings. And when it comes to any sort of decision making, like you see in business, there are many different variables that can affect one's process. These can range from things like your emotions at the time, your cognitive workload, stress, motivation, risk aversion, biases, and many others that can affect your own rationalization and eventually the kind of behavior that you decide to take. Now, when it comes to the study of business and when it comes to the study of decision-making process, the easiest way to sort of suss out these different variables is simply to ask and say, hey, what made you want to buy this product or see this movie or consume this item? And self-report and surveys have been around for a very long time and they're popular for a reason. But there are many different sort of variables that can affect the answers that you get from these other methods. For example, we have our own internal biases that affect how we might articulate how we feel. Maybe if we want to give our rationalization for a particular decision, we kind of want to say what we think the experimenter wants us to say. So we'll often filter our own output into something that we think is a little bit more socially acceptable. Or we might not even remember in the moment what we reacted to a particular thing at a particular time. And if we can't remember it, we can't articulate it. Even the lexicon that we use, the emotional language that we use, and this especially applies for people for whom English is a second language, we might not have the vocabulary to articulate how we might feel or how we might react in the moment. So survey and self-report are great. They get you a lot of really good answers, but they don't really get at the sort of moment-to-moment unconscious reactions, behavioral reactions that we're making at any given time. And that's really where the use of physiological data or biosensors really comes in. Because what biosensors allow you to do is record the physiological output, the physiological reaction of an individual to a stimulus right in the moment without conscious intervention. And there are different tools available that can be used, and they can give you different pieces of information like attention or valence or physiological arousal. And we can look at where people are looking and what are they noticing. How intense is their reaction to them? Is that reaction good or bad? Are there items that are getting missed? What might be their cognitive workload at the time? And many others. So we're not proposing by any means that the use of physiological data is intended to replace survey and self-report, certainly not, but rather act as a complement to have these tools together to provide a holistic view of how someone is reacting to something and subsequently how that might affect their process in the future. Now, the great thing about different sensors is that they each give you different pieces of information. I like to call it sort of the biosensor toolbox. And here are just a couple of different examples. Eye tracking, for example, can give you visual attention. So am I noticing key information? How long am I looking at certain things? Are there certain elements that get ignored? And within the umbrella of eye tracking, we can have different sensors like screen-based eye tracking for looking at websites, glasses, or even VR. Skin conductance can give you something like arousal or salience. Facial expression analysis can give you a sense of, am I reacting positively or negatively to something? And then there's many others. We can look at muscle activity. We can look at heart rate. We can even look at brain waves. I know sometimes you think of brain waves or EEG and you think of the big cap with the cables coming off the person's head and it's very daunting. Well, there's actually many commercially available headsets that are available now that can allow people who are not scientists typically to look at things like EEG, brain waves, and behavior in a moment. So all of these different sensors are really powerful working together, again, to give you sort of that sense of how someone is reacting, what are they attending to, and what is the nature of that reaction in the moment. And far from being in the lab, the use of these tools has really extended to different kinds of industries. And there's a huge variety here, but if we pull up sort of the different roles in which physiological sensors can sort of take part in, there's a lot of commonality in here. So things like marketing and communications, consumer insights, product design, and usability. Now, when I talk to companies about the use of sensors, often they're daunted by the investment involved. And it is an investment because not only do you have to think about purchasing the sensors and the software to analyze that data, but you also have to think about other logistics like facilities, having a dedicated lab space where you can run these kinds of studies, hiring a research team, training them to have an understanding of the sensors and the science to be able to run these kinds of studies. And then eventually the logistics as well of recruiting participants, bringing people into the lab and scheduling them, compensating them afterwards, handling their data. So it becomes a lot. And for a company, especially a smaller company with a limited budget who wants to sort of dip their toe into this technology for the first time, there is a very high sort of obstacle in the way in terms of this investment. But one alternative that we can consider are the use of remote tools, which remove the need for this sort of in-lab investment. Now, when I talk about remote tools, I mean sensors that you can actually deploy and collect data from remotely, as in you don't have to bring people into a lab physically, but rather you can collect from people within the privacy of their own home. And when I talk about remote tools, there's two that are primarily within that umbrella, and that's the use of webcam-based eye tracking and facial expression analysis. And as you can see here, both of these tools rely off of the webcam in order to collect data. So you don't have to collect, or you don't have to purchase any specialized piece of hardware or expensive scientific equipment to collect this. All you need is a simple webcam. And usually the webcams that can come, in USB format, or even the ones that are embedded in someone's laptop, can be used as research tools in this case. Now, the way sort of this remote data collection works, and that you can do with the iMotion software, is typically you would design your study with whatever images or videos or websites even that you want. So this can be something like different package designs or a website that you want to see the usability of if people are navigating it, or doing a simple A/B test between two commercials or movie trailers, for example. You would create that study along with any surveys that you'd like to include, and you can upload that to a cloud service and then get a link, a URL that basically links to that study. And that URL is what you would then use to distribute out to your participants. And the great thing is that you can distribute it whichever way you like. You can use a panel provider if you needed specific demographics. You could also email it to people. You can throw it up on LinkedIn and just have a free-for-all with it. So it's really easy to collect people, not only many people at once, but also, again, to not be restricted by geography and to be able to collect from a large group of people from different areas at the exact same time. You can actually monitor the progress of data collection within the platform and see how many people have completed your study and how good their data is. And then you can download that data and analyze it and then get some metrics and some usable insights from it. So a quick primer on the tools themselves and how they work, and then we'll get into some examples of what data might look like and some use cases in which we've seen this technology. Webcam eye tracking works again through the webcam and specifically uses computer vision. So if you were to actually look at an in-lab eye tracker, it actually uses infrared light to detect the eyes. This is sort of the kinds of hardware you would use in a lab. But with an eye tracking webcam, you're essentially using computer vision to detect the face in the camera and detect the eyes, and then essentially map where someone is looking on the screen based on some calibration data that you provided. When you get that data, you can actually visualize it in different ways. And here's one such example of a study where we showed people the same image over and over again, but then asked them different questions about the image, like what are the ages of the people, or what clothes are they wearing, or what are the material circumstances of the family. And what these colorful blobs are heat maps. So these are visual representations of everyone who's looked at these images and specifically what they're focusing on. So the hotter the color or the more red the color, the more people and the more attention is being paid to those elements in the photo. And then green is maybe a little bit of attention. And then if there's no color there, then it's not being noticed at all. What this image shows us is that depending on the context or the question or the information that we're looking for in that image, our gaze patterns are very different. So for example, when we look at the ages of the people, we might focus more on faces, whereas if we're looking at their material circumstances, we can look at the various features of the room, like the photos on the wall or the piano or the clothing they're wearing. What we look defines our attention and vice versa. And we can take advantage of this concept with regards to commercial research and eye tracking. A little bit more of a relevant example here. This is an example of eye tracking done on package testing. So in this case here, we have different prototypes of different packages and package designs. We might have a couple of different prototypes and then also some competitors that we've thrown into the mix. And what we can do is, again, use eye tracking to look at, first off, where people are looking on each package. That's the heat map down here that we see on the bottom. So we can see, do they notice things like the logo, any special sort of offers up top or information that we want to showcase? Are people noticing that? But we can also derive things called areas of interest. And areas of interest allow us to derive some more specific metrics, like which one of these items on the shelf did people notice first? For example, which one of these was more eye-catching? Subsequently, out of all of these different bottle types, which one did people look at the most or the longest? How many or what percentage of your respondent pool actually noticed your target? And these are specific metrics or numbers that we can calculate from the eye tracking data and that you can run statistics on. And these can give you actual quantifiable insights on where people are looking and how your product is doing in this case. Facial expression analysis is the other tool that you can get using a webcam. And what facial expression analysis gives you is a sense of valence, or sort of the emotional content of the person as they're experiencing a stimulus. It works in a very similar way using computer vision and in this case, deep learning. But what these engines do, and we work with two, Affectiva and Realize, what these engines do is they take a webcam video feed of a person, isolate the face, and basically quantify what facial expressions are being made at a given time. Now, I want to sort of add two caveats to this explanation. The first is that this is not facial recognition. We do get the occasional question about, the security of these kinds of tools and whether they're used for any sort of identification purposes or security purposes. And that is a very different beast. We're not identifying anybody using this technology. We're actually sort of applying their face to a template and then trying to look at, are they smiling? Are they furrowing their brow? Are they widening their eyes or opening their mouth? So there's not any sort of identifiable or sort of security information in that. It's simply expressions and nothing more. The other caveat is sort of this link between facial expressions and the emotions behind them. I think there's a lot of conversation technology and how far we can sort of interpret the data. And all these tools give you are what is being expressed on the face. And granted, facial expressions are a social signal. They're what I use to convey my emotional state to people, but it is not the same as the emotion that's being felt inside. They're two different things. So we've all seen examples of, say, actors, for example, who are very good at emoting outwardly, but might not feel the emotion internally. We also know some people that are very stoic in their countenance, but then can also be very emotional once you get to know them, right? So this tool is really intended to quantify what is being shown. So in some examples, thinking, if I have a joke in a commercial, did the joke land? Did people laugh? Or is there confusing information in my product or what I'm trying to test that makes people sort of make this brow furrow face, right? So we can look at different expressions that are being made and then use that to sort of guide our decision making. Here's one such example of how facial expressions are being used in commercial research. And this is specifically in health communications. It does come from a university, but what we're learning here is really applicable to many different industries. So this is from a lab at the University of South Florida. And what they did was used facial expression analysis to look at people's reactions to COVID infomercials. So they actually partnered with a healthcare provider, Baycare Health System, to recruit people to look at videos and infographics about COVID-19 messages and vaccines, and to evaluate people's responses to the information. Are there things that confused people, that sort of made people make like a confused face? Or, are there parts that, resonated with people or even made them angry? So we can look at people's reactions to that and then use those insights to fine tune that messaging to make it more accessible and impactful to people. Another example is anti-tobacco PSAs. So again, by the same group, but looking at facial expression analysis to a range of different anti-smoking PSAs to see which one of these is most impactful based off of the facial expressions people made. And there are a couple of PSAs that were deliberately intended to invoke disgust. And those, they found that the greater the disgust expressions being shown, the more impactful the ads were shown to be in self-report and survey. So these are just a couple of different examples of how facial expressions can be used to evaluate media, and these can definitely be extrapolated to different commercial applications. So I wanted to sort of keep it short here, but this is just sort of a quick example of how these tools are getting out of the lab and can be used remotely by small businesses and people that want to try and dive into this technology for the first time and see how human behavior tools can impact their business. I'm from a company called iMotions, where we provide the software that allows all of this data analysis and collection. We also provide biosensors and hardware, and more specifically, and why I'm here today, the support and services and the training that we provide for a lot of our clients. Many of our clients are not neuroscientists, but do want to sort of see how these tools can be applied to their business. So customer success is really important to us, and we believe a lot in education and in training. And we power over 1,000 academic and commercial labs worldwide. These can include major universities in different departments such as business, communications, education, and so on, and then also commercial users all around the world. Many of these large companies you recognize for many different applications like consumer insights, shopper science, and usability, and many others. So this is only just a quick taste of the kinds of technologies available to you. If you would like to learn more about different sensors and how they can be used for different applications, I would encourage you to come look at our blog at imotions.com/blog, or to reach out with any questions. And I'm happy to talk to you more about the potential of these tools in your business. Thanks.